Modern engineers use laser levels, computer-aided design, and precision machinery to achieve millimeter accuracy. Ancient Egyptians had none of these tools. Yet the base of the Great Pyramid is level to within 2 centimeters across 230 meters. That's an error margin of less than 0.01%. The sides align to true north with an accuracy that wasn't matched again until the invention of the compass, 3,000 years later. Either we're underestimating their capabilities, or we're missing something fundamental about how they worked. Stand at the base of the Great Pyramid of Giza, and you're looking at 2.3 million stone blocks, some weighing up to 80 tons, assembled with precision that rivals modern construction. The base is level to within 2 centimeters. The sides align to cardinal directions with incredible accuracy. Inside, granite blocks fit together with gaps too thin for a human hair. This is Bronze Age engineering, built around 2560 BCE. The question that's puzzled engineers, archaeologists, and enthusiasts for centuries is simple. How did they do it? Let's quantify exactly what we're talking about. The Great Pyramid's base covers 13 acres, yet all 4 sides are equal in length to within 5 centimeters. That's a margin of error of 0.02% across structures stretching 230 meters. The pyramid is aligned to true north with an error of just 3 arc minutes, roughly 0.05 degrees. We didn't achieve that level of directional accuracy in Western architecture until after the magnetic compass was perfected. Inside the king's chamber, the granite blocks present an even greater puzzle. These aren't limestone, which is relatively soft. This is Aswan granite, one of the hardest stones in Egypt, containing quartz crystals that rank 7 on the Mohs hardness scale. Each block weighs between 25 and 80 tons and was transported over 500 miles from southern Egypt. The precision of the fitting is extraordinary. When Egyptologist Flinders Petrie measured these joints in the 1880s, he found gaps of 1/50th of an inch, about half a millimeter. In some cases, the fit was so tight that even with modern measuring tools, detecting the seam was difficult. No mortar was used. The blocks simply rest on each other, held in place by weight and precision cutting. The Valley Temple at Giza presents another example. Here, some limestone blocks weigh over 200 tons. They're fitted together with such accuracy that you cannot insert a knife blade between them. This isn't 1 or 2 showcase pieces. This is standard construction practice repeated across hundreds of thousands of blocks. Here's why this seems impossible at first glance. Ancient Egyptians were working in the Bronze Age. Their hardest metal tools were copper or bronze, both much softer than the granite they were cutting. Copper ranks about 3 on the Mohs scale, granite ranks 6 to 7. It's like trying to cut through steel with aluminum. It shouldn't work. They had no pulleys as we understand them, no wheeled vehicles in any practical construction sense, and no written records explaining their exact methods. The Egyptians documented many aspects of their culture, but they left surprisingly few technical manuals about pyramid construction. Modern construction achieving similar precision requires laser levels, computer modeling, precision-cut diamond tools, and cranes capable of lifting hundreds of tons. We have GPS for alignment and digital measuring tools accurate to microns. The ancient Egyptians had none of this. So when people ask how did they do it, the question is genuine and substantial. This precision gap has led to various alternative explanations. Some propose that a lost advanced civilization predating Egypt passed down the technology. Others suggest extraterrestrial intervention. There are claims of sonic levitation, crystalline power sources, or techniques involving water and vibration. These theories are popular because they offer simple explanations for a complex puzzle. If ancient Egyptians had lasers or anti-gravity technology, then of course they could achieve this precision. The problem is, there's no physical evidence for any of these technologies. No ancient laser tools, no anti-gravity devices, no remnants of power plants or advanced metallurgy beyond what we already know they possessed. What we do have is evidence of conventional tools, experimental records, unfinished monuments showing construction techniques, ancient quarries with tool marks, and most importantly, modern experiments successfully replicating Egyptian methods using only Bronze Age technology. Let's look at what we actually know. Archaeologists have found extensive evidence of the tools and techniques used. Copper saws, chisels, and drills have been discovered at construction sites. At the granite quarries in Aswan, you can still see the marks where these tools were used. Ancient workers would cut channels around the blocks they wanted to extract, then use wooden wedges. They'd soak the wedges with water, causing them to expand and crack the stone along predetermined lines. But how do you cut granite with copper? The answer is you don't, not directly. You use abrasives. Ancient Egyptians had access to quartz sand, which is harder than copper, but also harder than most stones. They would use copper saws and drills, but the actual cutting was done by the quartz sand mixed with water. The copper tool simply holds and guides the abrasive slurry. In the 1980s, stonemason Roger Hopkins and Egyptologist Mark Lehner conducted experiments for a Nova documentary. They successfully cut and moved multi-ton limestone blocks using only ancient Egyptian tools and methods. They used copper saws with sand abrasive to cut through hard limestone. It was slow, taking hours to cut through a few inches, but it worked. More recently, engineers at Waseda University in Japan replicated the drilling technique. They used a copper tube drill with quartz sand and successfully bored through granite. The drill marks matched those found on ancient Egyptian artifacts. The technique requires patience, not lost technology. For the precision fitting, evidence suggests ancient Egyptians used a technique called scribing and grinding. They would place two stones together, mark the high points, grind those down, test the fit again, and repeat. This iterative process, combined with flat copper tools and abrasive powder, could create the tight tolerances we see today. It's time-consuming, but entirely achievable. Egyptian precision wasn't just about tools. It was about knowledge. Ancient Egyptians were sophisticated mathematicians. The Rind mathematical papyrus shows they understood geometry, fractions, and algebraic equations. They could calculate the area of circles, the volume of pyramids, and the slopes of structures with remarkable accuracy. For astronomical alignment, they used the stars. The Egyptians aligned pyramids by observing the circumpolar stars, stars that never set below the horizon. They would construct a circular wall, then observe when a star rose and set relative to that wall. The midpoint between these two observations gave them true north. Experiments by Kate Spence, an Egyptologist at Cambridge, confirmed this method could achieve the precision we see in the pyramids. For leveling, they used water. By creating water-filled trenches around the construction site, they established a perfectly level reference plane. Water always seeks its own level due to gravity. Simple, elegant, and perfectly accurate. For measuring, they used ropes and rods. A standard cubit was maintained by royal decree, with master measuring rods kept in temples. Ropes could be stretched taut and marked to create reliable measuring tools. Ancient Egyptian surveyors were called rope stretchers, and evidence suggests they used Pythagorean principles to create right angles. Stretch a rope with knots at 3, 4, and 5 unit intervals, and you have a perfect right triangle. Here's the critical counterpoint. Precision doesn't require advanced technology. It requires time, skill, and standards. Think of medieval cathedrals. Gothic stonemasons created incredible precision with hand tools. Japanese temple carpenters using traditional joinery create wood joints that fit without nails or glue, with tolerances as tight as Egyptian stonework. These techniques rely on mastery, not machinery. The ancient Egyptians had something modern construction often lacks: time and unlimited labor. Pyramid construction was a multi-decade project employing tens of thousands of skilled workers. When you can take 20 years to build a single structure and have master craftsmen dedicating their entire careers to perfecting techniques, precision becomes not just possible, but expected. There's also survivor bias. We see the pyramids that remain, The most perfectly constructed monuments, numerous other structures from the same period didn't survive, either because they were less well built or because they've eroded away. We're looking at the absolute best of Egyptian engineering, not the average. Finally, the question, why don't we build this way today, has a simple answer. We don't need to. Modern construction prioritizes speed and cost-effectiveness. We could replicate Egyptian precision if we wanted to spend decades hand-fitting stones, but we have better methods for our purposes. That doesn't mean their methods didn't work. It means our priorities are different. What the Egyptian precision really demonstrates is the power of human ingenuity when given clear goals, sufficient resources, and time. These builders faced problems and developed solutions through trial and error, observation, and mathematical reasoning. Consider their use of leverage and counterweights. They couldn't lift 80-ton blocks with pure muscle power, so they developed ramp systems and rockers. They understood mechanical advantage long before Archimedes formalized the principle. They observed that wetting sand reduces friction, so they dampened the sand in front of sleds to move heavy stones more easily. A technique confirmed in a tomb painting and validated by modern physics experiments. They developed specialized tools for specific tasks, different copper saws for different stones, drills of various sizes, measuring instruments calibrated to royal standards. This is sophisticated engineering, planned and executed over generations. Perhaps most impressively, they institutionalized knowledge. Master craftsmen trained apprentices. Techniques were refined and passed down. Quality control was enforced. This wasn't random luck or magical technology. It was organized, systematic engineering on a civilization-wide scale. So how did ancient Egypt build with such precision? The answer is both simpler and more impressive than lost technology or alien assistance. They did it through human intelligence, patience, and skill. They used copper tools with abrasive slurries, water for leveling, stars for alignment, and geometry for measurement. They employed thousands of trained craftsmen working over decades to achieve results that still astonish us today. The real lesson isn't that ancient Egyptians needed advanced technology. It's that we don't need to diminish human capability to explain human achievement. When we give people time, resources, clear objectives, and respect for their intelligence, remarkable things become possible. What do you think? Does understanding the methods make the pyramids less impressive, or more? Let me know in the comments. And if you enjoyed this exploration of ancient engineering, subscribe for more deep dives into history's greatest mysteries. Thanks for watching.